Yeah.
Okay, so what I have here is a coil of wire connected to a power supply. It's running about 2 amps of current there. I'll dial that in just a minute. But so in this case, the current's coming in right here. We can see it's a 10.5 centimeter radius. And if you look where the sensor is located, I'm just going to try, the quality of the measurements isn't that critical here. I'll explain why in just a minute. But so you can kind of see approximately where the field sensor is located. Whoops, sorry, I was pressing on it there. By that white dot right about there. So if I can get some numbers there so you can see it. Hopefully you can get that measurement. So it's approximately at the center, maybe plus or minus a half or even 1 centimeter. So notice this sensor is only going to give us 2 sig figs, sometimes only 1 sig fig. So I'm not too worried about that little error there. That said, we noted it. So the idea is, as I move this thing on axis, hopefully you can measure the magnetic field. And just before we start, let's verify. I pulled the cable. And so notice there's no magnetic field being registered here because I zeroed it out just before we started. So now we're not seeing any stray field from the earth. Alright. Now I'm plugging it back in. We still got a number. So let's go ahead and go over here about, let's say 16 centimeters. And I'm trying to do the best I can to line up this sensor where I believe it is in there. And so there's a little slop in there, again, probably a half centimeter at least, maybe a centimeter, probably a half. Okay, and so I'm just going to cruise along, and you can record the magnitude of the magnetic field as a function of the distance along the axis of the coil. Alright, so this is 16 centimeters away from the center. And notice our current is now 2 amps. Okay, so 16 centimeters, 14 centimeters, 12, 10, 8, 6, 4, 2, hard to see this one. So right about there. That's right at the center of the coil. 2, 4, 6, 8, 10, 12, 14, there's 16.